Econ 378 is to do a data project. The objective of this data project is to show your mastery of materials that we've covered in 378 with an application to the real world. So that's kind of the guiding principle to think about, is how can you use the principles learned in 378 to shed light on a new topic or to answer an important question. So this is going to be a walkthrough of just a brief tutorial of different ways you can use STATA to do a project. This is not the only way. And in fact, I might recommend not to follow the exact steps I do in this way, but I have a research question, a topic I'm interested in, and I want to be able to try to answer that topic using data. So let's first look at the topic. I want to know what is the relationship between age and earnings. So I'm using data from ACS Lab 1. Where this data comes isn't so important for this tutorial, but as I'm thinking about my project, section 1 is the introduction. So I'm not going to have a lot of introduction here in my STATA code, but in my paper that I write out, I'm going to talk about why this is an interesting question, why it's important, maybe what are some things we already know about it from past studies, and things to that effect. So here's 2 reasons why I think this is an interesting question. The first is, as you graduate from college and you get your first job offer, the question is that going to be your wage throughout your life? Well, I hope it isn't. Part of this is that we can show what that relationship of earnings looks like as you age. The second might be is something that happens in a legal setting. In personal injury cases, if someone is injured, then it's up to the court to determine how much they would have earned had they not been injured. And so part of this is to understand that relationship. Is some experts opine that earnings increase for each additional year you get older. So as you get older, your earnings go up. Others argue that not does it just go up, but it actually goes up, but then comes back down. And that relationship is really important. What they're arguing in those cases is the relationship linear or is it quadratic? And so that's kind of what I want to get at with this example, is to try to show what is that relationship. So in my paper, I'm going to look at the introduction. Section 2 is going to focus on my data analysis. This is kind of what we did on the first part of the data project. And I'm going to talk about where the data comes from and all that, but for purposes of STATA, I might just let's run a summary statistic of our key variables. So I might sum ink tote and age. So let's go ahead and summarize our 2 key variables. So here we have observations, over 2 million observations. Our average income is 56,850. Our average age is 42. We can even talk about our standard deviation. Definitely want to talk about our mins and max, because as I clean the data, I impose these restrictions. Not everybody in the US is between the ages of 18 and 65. And so that's what we can do in our data section. Well, the other thing I might want to think about is maybe let's show what the distribution of income looks like. And so if I do histogram ink tote, this is going to show what that distribution might look like. It's a lot of observation. It takes a little bit. So it looks like this, right? And so there's a very few observations here and there. And the question is, does this look normally distributed? And you might look at this and conclude absolutely not. And so this is where we can show this histogram. And I'd probably change the axes to make this look like a really good graphic for my paper. But I can just talk about what does the distribution look like compared to some other distributions we've covered in class. So that might be what I have for section 2, and talk about those things that I did. For section 3, this will be the new section we start to add. Here's the analysis. So the analysis I want to look at, well, let's just look at first, what is the correlation between income and age? So to do this, I would just use the command correlate, ink tot, and age. And I would run this command. I'm actually going to comment out the histogram so it doesn't create it each time. With 2 million observations, it takes a while to create some graphics. And we'll see that here in a little bit as well. But if I run the correlation, well, here's the correlation, 0.1682. In my paper, can I describe what this is, interpret what this means, and things to that effect? So here in STATA, I can calculate the correlation, but in my paper, I would need to write out and describe what that correlation is. Well, now I might want to get into some hypothesis testing. So maybe let's think of my first hypothesis. And maybe my first hypothesis is I read a news article that's something like this. I see that the average annual salary in the US is $6,622. Right? Well, let's go ahead and have that be our first hypothesis. So the first hypothesis, my null hypothesis, is that the population mean is equal to 66622. Okay, well, I can use my data to test this. So this is hypothesis 1. I can do t-test inc.tot is equal to 66622. And when I run this, it'll actually run the t-test for me. So here's my mean. Here's my t-statistic, or my test statistic. And then here is the probability. Notice that that p-value is really small. And that t-stat is really big, right? That's like 1,700. Or 1,700. So that's really big. And so I would reject the null that they're the same. So from this, I would then in my paper talk about and the result of that hypothesis of why they are different. So I found evidence, I reject the null that they're the same and conclude that they are different. But why? Well, as I look at this number, this is actually the average, not just the salary, but this is the average household salary, which means this is by household. So if I have 2 income individuals, then this would calculate both their income. In the ACS data, Inc. total is the total personal income of the individual. And so that might be the difference in between these two numbers. So in my paper, I might talk about why I would reject that null hypothesis and what that means. So there's my first hypothesis. Then my second hypothesis, I'm going to have to build up to. But what I want to argue is the relationship between income and age is not linear. I mean, it's not just a straight line. So maybe let's go ahead and do something here. So we're going to create age categories. So I have a variable for age, which is individual years. But I want to generate, let's call it age group equals 2. So I'm going to give everybody a 2. And then I'm going to replace age group equals 3 if in range, if age is between 30 and 39. So what I'm going to do here is create different variables based on the age groups. So if you're between the ages of 40 and 49, I'm going to put you in group 4. If you're between the ages of 50 and 59, I'm going to put you in group 5. And if you're above, if age is greater than or equal to 60, you're going to be in group 6. So what this does is those who are 18 to 29 will be in group 2. Those who are in their 30s will be group 3, 40s group 4, group 5, and group 6. And so what I can do here is I can tab age group. And when I run this, this will tell me the fraction. It's not do not rage, but to in range. Totally different than raging. So it's very common to make mistakes in STATA. The key is, can you identify your mistakes, then improve upon them. So here it is. So those who are 18 to 29, I have 23% of the sample. Those that are in the 30s, I have 20% of the sample. 20% in their 40s, about 21% in their 50s, and about 15% that are in their 60s. So those are the different groups that I have. Well, what I can now do, now that I have those groups, I can look at by cis, or by sort, age group, sum, inc.tot. So this is now going to calculate the average income for each of these different age groups. And I need to make sure I have a semicolon there. So those that between the ages of 18 and 29, their average income is $27,000. Those that are in their 30s is 60, in their 40s is 72, in their 50s is 70, and the 60s is 59. So notice that it's increasing and then it starts to decrease as you get later into your decades. So this would suggest that it's nonlinear. Well, let's just go ahead and do a t-test. Is this number statistically different than this number? So your earnings in your 50 different than your earnings in your 40s. So now here comes really the hypothesis 2, when I'm going to do an actual hypothesis test, where my null hypothesis, yeah, I like that O better than the 8 and 0. Null hypothesis is that my mean income in 40s is equal to mean income in my 50s. So to do this, I would do t-test inc tot if age group equals 4 or age group equals 5 by age group. So I'm saying let's only look at when there are 4s and 5s, and let's run a t-test between those two categories. And that's going to run the test between those that are in their 40s and 50s and not other categories. And so one way I can make sure to check this is now running our t-test here. Notice that my mean right here for the 40s is the same mean I calculated here. My mean for the 50s is the same mean I calculated here. And this finds that the t-test statistic is 7.83. The p-value is 0. So I would reject the null that they're the same and conclude that they are statistically different from one another, meaning that the earnings in your 50s is lower than your earnings in your 40s. And that would argue for this nonlinear relationship. So that's one way I can do a t-test for that. Well, maybe I could say, well, let's look at a regression analysis. Right? So what would a regression analysis show us? Well, I can run a regression, regress inc tot on age. So I'm just going to look at years here and not age group. And when I run that, this is going to give me a, well, when we talk about regression analysis, we're doing ordinary least squares, right? Or linear regression, it might be called. So here is my intercept, and here is my age. And so this is going to calculate that relationship. So I can actually open up Excel real quick just to kind of show you what way is, we don't have to do everything in STATA. We can use Excel when it's appropriate. Let's see if we can get that to open. So as Excel opens up, what I'm going to do is I'm going to copy my coefficient. So this is beta 1. My beta naught is my constant. Is I can have here age, 18, and I can get my age here all the way down to 65, and now I can come up with my predicted income. So this is equal to beta naught hat plus beta 1 hat, we're going to anchor these here, plus beta 1 hat times x. So this is my predicted wage for each of these age groups. And now that I have that, I can come right here into Excel and create a line chart. Let's select the data for our x variable. So x is going from 18 to 65. Uh-oh, that's not good. So it's a little jagged. That's not supposed to be. And that's because I have 18, 19, 19. So let's just go ahead and click there. And so now as I come to my table, That's going to 110. I don't probably need to go to 110. So let's select the data. Let's edit it. The values, let's just have those go from 18 to 65. And our x values, let's have those also go from 18 to 65. So now with this chart, I can add titles and different things here. This shows the linear relationship. Well, this is similar to a correlation, right? It's just showing that linear relationship, but this is not showing a nonlinear relationship. So again, I can use regression analysis to show a linear relationship, but I really want to get at this notion of, is it nonlinear? Because that's what this table shows right here. So I would talk in my analysis about why I think it's not linear, and this is one of the driving factors. Well, can I graphically show that? Well, one way to try to graphically show that is, let's look at graphically show relationship between age and income. So I could just scatter plot income and age. And so when I run this, it's now going to create this scatter plot to try to show that relationship. And this is going to take a little while to run. There's about 2 million observations 2 million dots to put on this. But notice that for each age group, that's going to be each of these individual bins, there's a lot of different observations for that. And so because there's so many observations, it's really hard to tell the relationship between age, which is on our x-axis, and income, which is on our y-axis. So each axis is going to, each tick here on the x-axis is going to show a specific age, and we just don't quite get that. So one thing we could do is we could collapse the data, so for each age, it'll create an average of the income for that age. So here's 18, let's create an average for 19, let's create an average for 20. To do that, we would collapse our data. So I'm going to comment this out so I don't have to wait for that graph. So I'm going to collapse data based on age. So now I collapse. I'm going to calculate the average income for each age group, or for each age, not group, but by each age. And then once I collapse the data, I can then run that same scatter plot, but rather than each individual observation, it's going to show the average income conditional on each age. So this is the expected income conditional that X age is 18. Expected income conditional that age is 19. And this now is really strong evidence to suggest that the relationship between income and age is nonlinear. I can show my best fit line. Notice that this is the best fit line here that we did with our regression analysis. But that's just showing that if I were to do a best fit line for these points, it's still going to be positive, but it's not going to be a very good fit. And so this shows that nonlinear relationship. So now in my paper, I can add my conclusion about what do I conclude based off of this question of what is the relationship between age and earnings. Based on my analysis, I would argue that that relationship is nonlinear, even quadratic, and it is not a linear relationship. I hope this gives an example of how we can use STATA to clean data, to analyze data, to help use data to answer a question or inform us on an interesting topic.